Hello. I'm getting ready here. Playing with my sound levels a little bit. Making sure my preamp or whatever is set up properly on the Focusrite. That sounds alright. What do you think? I think it's okay. Music might be a little loud. I haven't turned it down yet, but we'll get there. Still working on something. I'm live. Still live. Hello. It is I, Jos. Yeah, today we're blasting off with, oh, I didn't set up my other webcam. Oops. Hang on. My other webcam is a phone that I have ordered a tripod for. Might as well show you my face. I have ordered a tripod for this, but it has not arrived. And then actually, let me make sure that this guy is working. No, he's not working. Why not? Why not? So hit me with the virtual cam. There it goes. Okay. Interesting. I wish I didn't have to set this every time, but I do. For this view, this needs to be set to webcam mode. And then there's a preview. A button I can press to set it to HD or not. And then wide mode. You can't see this yet. I have to redo the properties on another scene. So hang on. Oy vey. Alright. Now you should see the virtual camera show up there. Yep. And then Android. Hey! There it is. So you can see the trash that I have on the floor. Oh, this fell off. Of my desk. There we go. Nice and messy. Cool. Don't need that. Can move some of these. And okay. I think I'm all set up. The only other thing is I think this view has the webcam from over here. Hi. Yep. I was just checking that. It's actually larger. That's okay. And then it also has some kind of... It's grabbing stuff from Safari. I don't think I want to keep that around right now. Go away. Yeah, remove Safari audio capture. Actually, I'm not sure. Well, yes, there are two things I want to do today, and I'm gonna put that in the. The message over here. Get rid of this for the moment. Start with a post for social medias. Volume's down. Pretty good. That's a good balance. Let me know. Yeah. Enu. We'll just open this directory. All right. Whoops. There's a shortcut for this. It's Control X, Control J. Oh, but I didn't save this. So I'll save this. Control X, Control J. Hit big R to rename blastoff.txt. And then open that up. Okay, so today, streaming live. I think last streams was pretty good. Let me take a look at what I did last time. Oh, I can't do Tuesday again, so streaming live. Thursday stream happening 2 to 6 p.m. Eastern on, and I'll do the link, twitch.tv. Oh, did I think I reset my font. I'm gonna do that now because otherwise I'll forget. 14? I think it was 14. 14's good. That's me. Let me make sure I turn the shuffler on over here, since I remembered. Happening live. Oh, it's doing the autofill mode. Let's see. Fill mode. Autofill. So autofill mode does the automatic line wrapping. We're seeing it do there. When it gets to 80 columns, it'll insert new lines. Thursday stream happening now. Happening now. Join me for one of. Join me 2 to 6 Eastern Join me 2 to 6 Eastern for one of the only embedded system development streams on Twitch. Today I am... What am I doing? Today I am adding... First, we're gonna get... What are we gonna... We're gonna optimize it a little bit for power. So we're gonna measure power. And then I'm not gonna put this in there, but I am also going to actually publish the code in a repo. I haven't done that. I don't know why I've neglected to do that. It's very dumb. I've been committing it the whole time and just not pushing it anywhere. So that'll be up online somewhere. But yeah, today, that should be quick. So today I'm optimizing for power. And then assuming I have time, which... Yeah, maybe. Assuming I have time, then I'm going to get into... Well, I might do these in the opposite order. Yeah, today I am setting up... setting up live debugging. What do we call those? Interactive debuggers? Setting up the interactive debugger and then optimizing for power consumption. And then beginning to optimize for power consumption. Yeah, and then I am going to be on vacation after next week, I think. Let me see. Calendar. So it's going to be rough. So next week, I think Tuesday and Thursday next week still on the table. Potentially a short stream on Thursday, but then I'm basically I might be able to do the following Tuesday, the 20th. And then I'm out until June. Yeah, I'm out until June. Unless you want me to stream like being in an airport, that's not gonna happen. So, yeah, I'll post more details of that somewhere. I'm not sure where. Anyway, hashtags, because I guess is that relevant? I don't know. Embedded development, hashtag microcontrollers, hashtag C++, hashtag programming. Today, I'm setting up the interactive debugger, setting up interactive debugging, and then optimizing power consumption. Okay, I think that's good. Whoops. Control XH to select the whole buffer. Alt or Meta W. For one of embedded system development stream. I think this is true. I at least last time I did a search and I only got one hit on that. So let's see. New post, blue sky. Da-da-da. Is that link correct? That's a good cue. Yes, that's the right link. post that. Whoops. Take this. Post that. I'll get rid of programming because character limits on Twitter. And then Fostodon. Whoops. What's on my mind? It's promotion of myself. Post. And then I guess I don't necessarily want to, but I guess I'll post on LinkedIn. I'm not going to verify my identity on LinkedIn, thanks. I hope it doesn't, like, email people. We'll see. Okay, so before I actually do the interactive debugging stuff, and the reason I want to set it up first is that it will come in handy for optimizing the power debugging. Yeah. So first thing I want to do is actually push up this repo. So git, what do we do? Git push. How do we do this? Git push. Yeah, git remote add. Yeah. Git remote add. And then I like to put it on my source hut, and there's a little trick you can do where basically it knows that if you push to a repository that doesn't exist, like, under your account, it'll automatically create it, which is cool. Let's see. So git remote add, git at, it's git.sr.ht, and then I'm Jose. And what should we call this? Do I already have a... Do I already have a view or a version of this pushed up? I do not, so I'm just going to put Compost mon here. Go. I didn't give it a name. Origin. And I can push. Yeah, git push. I have this alias for this. Git push up. It does exactly this. And then how do I... Yeah, see? I've pushed to a repository which did not exist. It's been created automatically. I think I actually need to go in here to make it public, because they're private by default. Settings, public. And I can give it a description. Work in progress from stream at, I'll do twitch.tv. My username. How's that? Couldn't find a license. That's true. I did forget to do that. Thank you for reminding me, Source Hut. This is going to be... It is of little consequence, I think. So I'm going to hit it with the MIT license. Or, let me see. GPL licenses. That should take me to the GNU site. I'll hit it with licenses. License list. Let's see. Licenses. Free software licenses. I think the good one is the Apache license version 2. Maybe. Let's see. There's an FAQ somewhere. FAQ. FSF, which license to use? They recommend one for small stuff. How to choose a license for your own work. Let's see. Small programs. It is not worth the trouble to use copyleft for small programs. We use 300 lines as the benchmark. Among the permissive licenses, Apache License 2 is the best. Yep, so we'll do that. License text. How to apply this to your work. Attach the I should show you this. Attach the following to attach this notice with the fields enclosed in brackets replaced by your own information. Text should be enclosed in the appropriate comment syntax for the file format. This blurb. Okay. Yes. So I'm going to hit it with the grab all of this. Grab all of this. And put it in license. Is that how you spell license? Yes. Actually, they had a link to a text file for it. So let me just do that. I'll kill this, and then I'll use wget, and then flag. Is it big O or little o for where to put the output? Big O. Big O. Yeah. Big O. We'll do license. Okay. Take a look at that. That looks good. Cool. And then also create a README. And I can get rid of this. And in the README, I'm going to say Compost monitor project being developed live on Twitch TV. And then I'll hit it with the license. And then what does it say in license? Take this blurb. Copyright. The year is 2025. That's me. There it is. And I'm not gonna bother. Oh, there's only 3 spaces. 1, 2, 3 spaces. Yeah. Let's add an extra space. String insert rectangle 1 space. I think that can go away. And now this should show up as... It should show up as the license text on the Compost Mon page. Commit. Add license. And README files. And then push. I should I'm gonna do that. I'm gonna get mv readme to readme.md. And then git commit amend. What? There it is. Git push force with lease. All right, so now I guess not. I thought it would render MD files, but that's fine. Let's look at it. It renders it here. Cool. Okay. Now we can get started with the debugging. I believe this uses OpenOCD. Eclipse command line? What? It is recommended. Yeah, don't do this first. Recommended only if you are unable to use OpenOCD debugging. Sure. Here. Begin by completing the steps described under configuring ESP32 target. Actually, that's fine. I won't plug it in yet. Well, we'll get there. Wait, where did it take me? Once OpenOCD is installed, I believe it is, which OpenOCD exists. Once OpenOCD is installed, you can proceed to configuring the target with JTAG interface. That's what I have, yeah. Configuring the target is split into the following 3 steps. Configure and connect JTAG interface. Run OpenOCD. Upload application for debugging. This step depends on the JTAG and ESP board you're using. We have a kit that I'm pretty sure has JTAG built in. So it claims we're ready to launch OpenOCD. So, debug arguments OpenOCD field of build project description JSON file. Okay, let's take a look. So Compost probe should have a build. What is it called? Project description JSON. Okay. And actually, let me set the size of this thing as well. Plus. There we go. I want to rename the project. We'll get there at some point. But it's saying, what is the name of the field? Debug arguments, OpenOCD. I don't think. Okay, debug arguments. It's at the very, very end. Okay. ESP32 S3 built in. So we should be able to do OpenOCD and then paste. And it has to be plugged in. Okay. Ugh. I'm gonna just ban these people. Should I report them as well? I don't know how to do that. Spam. Yeah, spam. Scam? Bots? Viewership tampering. Bot. I don't know. Trying to sell fake views? Submit report. I don't know if that helps. Okay. Plugged in. Open OCD. Can't find that. Well, if we load the IDF environment and then we try this, better. Couldn't find or open device. It's plugged in and powered on, so I don't know what's up. So that's why I'm spending the time I'm spending doing this. Let's see. You may find, depending on the hardware used, open a specific target. W rover. Wait. Hang on. All configuration files are here of OpenOCD distribution. It couldn't find it. Yeah. So here it is. Not exactly what it says I would find, but so I think what I have is this rover thing. Let's see. I have this. Via external base probe like ESP prog. This is the one I'm using built in. Yeah. So that should find it. Why can't it? So maybe let's see, IDF. Well, let's see if that works. So IDF Pi, open OCD. Please check the wire connection to debugging device or access rights to a serial port. Is it because so what is the command? ls USB. It's not here? Interesting. Ah. It helps if you plug in the hub. Okay. So actually you can kind of see what I'm doing here. Now it should show up. There it is. Okay. So now if I try this, hey, look at that. So normally the way this works, without even looking at it, you'd have to open up a second terminal, and then from here you could do GDB. What is the command for it? GDB device? No. Let's load the environment. What does it say? I have to look. I'm out of practice. Container, yeah, project here. Provide some configuration files. There are already some GDB inits here. Yeah. So then... Oh, okay. Yeah, so you want to launch the custom GDB build from the environment. So run that. So we got the extensa, ESP. It should be all the binaries for... all the binaries for the tool chain. So here's where the compiler is. This is the preprocessor. This is a tool to like unmangle names, C++ names. But here's GDB. So GDB. And then it should, what is Q? The Q option, minimize startup output. I don't care. Flag X to execute a script, build, GDB init, symbols. Interesting. X, wait. I see. So this is a GDB init file, this is a GDB init file, that is, and that is. So rather than do that, I'm gonna paste this whole command line. What the heck? Paste. Okay. And then build blink.elf. That's not what it's called. It's called either helloworld.elf or Compost Mon or Compost Pro. But I think it's Hello World. There it is. So now GDB connects to OpenOCD, which is a server running on the same machine. Yeah, and now there's a breakpoint. So I should be able to hit Control-C. We break. We can do B on app main. We've set a breakpoint there. We hit R to reset. What? Reset. Restart. Start. Oh my gosh. I thought we'd be able to reset. What the heck? All right, continue. Um... Squeeze me. Here. Breakpoints and watch points. 2 hardware breakpoints. Okay. Del Burr. To delete all breakpoints. Reset. Restart. Connect. What the heck? Okay, I'm gonna kill this. IDF Pi GDB, please. So it does the same thing. It claims there was a reset, but why isn't it doing a breakpoint? Yeah. Mo reset halt. Okay. Burr, there's a breakpoint at CPU.c line 64. Okay. So what if I run it? Okay. Mo reset. Halt. It will then stop at break. It doesn't though. It's lying to me. See? It's a liar. It's a liar. Oh, I forgot to hit the done button up here, I think. So if I look at my stream info, yeah. Ugh. Okay. Is it because I'm not building with enough debug symbols? That can't be true because it has all these, all the source files and line numbers. Setting GDB target to CPU 0. As far as I know, that's the only thing I'm running anything on. Thread info thread. We got an idle 1. We got an idle 0 for various for both of the CPUs, I assume. Here's my thread that I created. It shouldn't exist yet, though. It should be... It should be off. I'm going to do a breakpoint on app main. Mo reset. Oh, there it is. No? Mo. Oh, well, then hit continue. Delbur. Yes. Breakpoint on app main. Mo reset. Halt. Continue. Run. Help target. No. Okay. I'm annoyed by this. Okay. So we're debugging this, basically. So this is what I'm used to doing. Get rid of this. And just do the elf file. And then monitor help. Monitor not supported. Wait, so what are these files doing? Okay. Kill this. Kill this. So in Compost Pro build, there are these GDB init files. What was it doing here? So it had a bunch. Oh, I thought I deleted them. Cute. There. Here's what I had. This. Mo. Connect. Connect. Help. Let's look at GDB in it. Source symbols and source connect. Okay. Source symbols and source connect. I can find those. Bind file at point. Oh, it's target. Yeah, target external. And then this told me way up top that it had a port open. Let's see. Listening on port 4444. Tar ext 4444. V must reply empty. What? Let's see. Tar. Target. Hook post remote. Hook post remote. What the heck is that? I've never seen that before. Yeah. Confirm off load bootloader. March for what? The add a symbol file, sure. Symbols and then load connect. Target 3333. Mo reset halt. Maintenance. Lush. Register cache. TH break. Main. Continue. No? Okay. Let's open this all up. So, source. Source this. Does it source anything else? No. Okay. It also does connect, which does this. But then in the fun, like how to do it instructions, there was all this other stuff. Here we go. Prefix map connect. What is prefix map? That's a new one. Prefix map. So in here, there should be a prefix map. There is no prefix map. Okay. Oh. Oh. Load. Error finishing flashing operation. What does that mean? Ugh. Alright, I'm gonna call this idf.py flash. Wow. Okay. Yeah. IDF.py GDB. Oh, there it is. Okay. I don't know if you saw what I did there. So I typed layout source. And anything in any command you can abbreviate to its smallest ambiguous form. I think L does not work. So I think that means something else. Help L. That is list. So layout can be la, and then there's a source mode, and this is the source mode. And then I should be able to do next, 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 next. Should skip over that. Hit it with the next, 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 and step through it one thing at a time. Up to 5 times. Reset the probe. Start the Wi-Fi. SNTP. SNTP. Okay. Delay for a minute. So yeah, I think it's working. That's cool. That's all I really needed. Task 1 complete. Less than an hour. So, yeah, I don't know. These debugger things are kind of weird. They like, since they're so like meta, sometimes you just have to try it again. I hate that, but it is what it is, I suppose. But it works, and especially for doing, like, actually doing something. It should be good enough. Oh. So now we've halted. We can do start one-shot measurement. Then we do read the sensor. We could do things like this, where we can print star E output. Print E output. Oh, okay. It recognizes it's... Alright. I don't have to dereference it myself. Yeah. It's a value of 205. There's nothing plugged in there, by the way. I haven't done that. Let me fix... I will fix this. Right meow. Oh, it's upside down. Well, I don't like that. Okay, what I can do is maybe rotate things around a little bit. How's that? That's better. Yeah? Yeah. That's pretty good. Like that? Yeah. That's pretty fine. You can even kind of make out the display. I don't think you're going to be able to make this. Let me see. Yeah, that's not really legible. I guess I can just put it there. What's that? That's not bad. It's not bad. Oh, come on. Continue. Just keep running. Okay. So now that we've done that, I can start trying to figure out power consumption. Actually, I didn't think this through because the stuff in my eyes. I didn't think this through because in order to be attached with the debugger, it's going to have to be providing power, and I don't want that. Because I want all the power to go through my ammeter. So this was all kind of a waste insofar as what I thought I wanted to do. But I do want to set up the ammeter here. How do I want to do that? Well, yeah. So actually, yes. Before we untether it, one thing we want to do is get rid of all this stuff it doesn't need. So, the display can go. Sharp display, get rid of that. Write instruction register. Nope, go away. We're not even doing anything with it. We can just delete it. I'm just going to delete it. Okay. What else? The LED. This pin. It can go away. I will... Let's change it to be quite a bit less frequent. We'll do 5 seconds. And then I just won't have it connected, which should be relatively low power. It should be relatively low power to keep it disconnected and just have it toggling on and off. That's not too much of an issue, because the output's going to be, nothing's going to be pulling the output down or up. But then we can watch it with like the logic analyzer or an oscilloscope, which I've not showed you an oscilloscope. I should do that. I don't know how to set that up here though. They're kind of bulky. And I would need to change the perspective of the camera so that you could actually see it. Otherwise, you're not going to see anything. It's like a... I guess I could grab it. Let me grab it. I should mute. Okay, so let me get up here. So this, keep dropping. Okay, sorry, cat. This is an oscilloscope. This is a cheap one I got a while ago. I got it on Amazon, I think. Supposedly you can hack these to be extra powerful than what they program it to be, so that they can sell it at a lower price point. But this is like 10 years old now, and basically it shows you can connect probes onto here, and there's an external trigger one as well. This one has 2 channels. There's some that are crazy, super expensive. They're like, you know, tens of thousands of dollars with 4 channels and like built-in logic analyzer capabilities. But this one, you plug in a little probe. Looks like this on the end. And then, you know, it kind of slides in there. And it's got this like rotatey, I think these called Molex connectors? That might be like a brand name Kleenex type situation, I'm not sure. So connect these. Usually they have a little adjusto-mat. On the end here. Where is it? There. It's got like a little hole with a little like flathead type adjuster, and that lets you tune in I think it's the capacitance, actually. I don't actually know what it's doing. But I know that on the end, these usually also have a little adjuster of some kind on the actual probe side, so that you can change the capacitance of it. So when you do 1x, for example, that means you're going to read the voltage as it is on the end of this. So this is a little witch's hat, I think. That's what I learned to call it. It's got a hook. Can you see the hook? Ow, ow, ow. It's got a little hook. You can clip onto wires. Like this one. Grabs the wire. And so you connect this to the wire, and then it's got an alligator clip usually that you can plug into ground. And then that adjuster, so this will read at 1x, it'll read the voltage as it is. At 10x, it'll read 1/10 the voltage. So like it'll attenuate the signal, but that lets you then, theoretically, that should have lower capacitance, which should interfere like with the circuitry less. So there's that. Once we actually use it, I guess I'll show you some of the features of this one in particular, but they generally all have a bunch of similar basic things, and then individual ones are going to have more advanced stuff. But the most basic stuff that it does is it lets you measure like the frequency of any periodic signals. They can usually do like analyze PWM and give you a pulse width stats of it. So like frequency, but like the pulse length, pulse width, and all that kind of thing. They can measure the amplitude. You can look at the voltage. If it's a steady state signal, you can see like just a graph of what it's at. So this basically graphs voltage over time. And it has some features to let you do some math on them, including when you connect two of these, doing some math against them so you can get the difference and plot a new waveform that is some combination of the two inputs that you've selected. Yeah, and then you can trigger capture based on certain conditions. So if you're interested in like when a signal is low and then it first goes high, you can have it start acquiring whenever it goes high, and it'll grab for some amount of time so that you have time to look at the signal. A whole bunch of stuff. We'll get into it if we need it. Which I think we will once we start looking at power consumption over time, but we're not quite there yet. So first, I'm working on the code. First, I'm working on the code to get rid of some of this stuff. So I'll get rid of the display. Got rid of the code for that. The probe. I think that's it. It's just the probe and the LED. VTask delay. Delay. That's before the main loop. Okay, yeah, so then every minute, wake up, look at stuff. Let's do every 30 seconds for now. And then, let's see. What am I looking at? I'm looking at... I don't think I have... What is a differential probe? I don't think I have that. Oscilloscope differential probe. I don't have a differential probe. It's got two thingies, but... oh, no. Active probe, differential probe. What does it look like? Oh, it's an active differential probe. I want a current probe, but don't really have that. So we have to make do with something. Shunt resistor. What is a shunt resistor? Creates a low resistance path to force most of the electric current through the circuit to flow through this path. Made up of material having low temperature coefficient resistance, commonly used in current measuring, called ammeters. How does it work? Ohm's law. I'm looking at this. What is using a... Consider an ammeter. It has a resistance RA. It measures a very small current IA. For exceeding the range of an ammeter, a shunt resistor is placed parallel with RM. What's RM? We have an RA. You haven't mentioned an RM. Do they mean RA? Yeah, that is correct. Current passes through resistor RS, the shunt current. RA, that's the measurement we're trying to do. Shunt resistor is used in the current measuring device. The size of the shunt register will decide the range of the ammeter. The size of a shunt... Did I say register? Resistor. That's why. The size of a shunt resistor is determined by the maximum current it can handle, which in turn depends on the desired voltage drop at its maximum current. So... Shunt resistor designed for max current of 100A and voltage drop 50 millivolts. Voltage drop at max current is these, yeah. Okay. Using Ohm's law, we can calculate the resistance needed for a shunt resistor based on the maximum current and voltage drop. Okay. So, does that mean we can just do a little something with this guy? Let's see. Yeah, let's just do that. Let's do a very small resistor. Or, well, actually, I might not need to do that. I might not need to do that. Let's actually, so first we'll get this loaded up. This code change. So do that, and then I will also, on a new session here. Run the server. So compost serve. Mix Phoenix spelled without any vowels. Server. Okay. Then theoretically, I should be able to hit localhost 4000. What was it? Yeah, 4000. Here it is. Today is May 8th, so it should know that it's May 8th, and I should see data coming in there. Or let me leave this open. Okay. Control page up. Yep. So we've flashed this thing. So it should be on and off every 5 seconds. Or 10? What do we set it to? LED app. No. LED toggle task every 5 seconds, theoretically. 1, 2, 3, 4, 5. That's pretty close. 1. 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay. Close enough. I was really good at the Postman minigame in Majora's Mask. We start ticking a clock at you, and you gotta guess. Like when it hits 10. You have to get 10 seconds exactly. Yeah, I was pretty good at that. Let me switch this back here for a second, and we'll do a commit. Let's see. Screenless version. Remove screen for power. And what I can do, I'll switch back here. So it's loaded up. The screen should be useless. I should be able to unplug it. Unplug it, get rid of the LED circuitry. Put back the moisture sensor. And then set this guy up as an ammeter. I think that'll work. So let's do that. All right. Before I redo the voltage divider, I'll set up the other bits first, because I suspect maybe the voltage divider might bump up our current consumption a lot. I'm going to leave the LED itself in there. I've just disconnected the path from the VCC rail down through the resistor. So I've taken the resistor off of the rail and just connected it to itself. That way, I can still clip onto the end of the LED. But now, the main thing I want to do is take... Instead of having this set up as a voltmeter, I'm going to set this guy up as an ammeter. Which can be a little counterintuitive and a little bit confusing. So, the thing you gotta know is that red is in and black is out, as you might expect. But there are, when you change the range of this thing, usually these have a range. There's like a smaller range and a larger range. That's why there are two red guys on most of these like multimeter things. See this one too? It's got two reds and a single black. One red is gonna this one in particular shows you can see here it says 1A. I don't know if you can read that upside down. It says 1A. Or, no, it doesn't. It says DC 10A here in yellow. Right? And then this other one, it lists like the functions there. This one also has 10A written on it here. And it's got like the symbols for all of the other functions. Right there. So you can see the... Oh, it's quite blurry. Focus! It's got the V, the ohm, the omega, microamp, milliamp, and that gives you the range. So now that I've belabored that point enough, the point is you're going to go in through the red, out through the black, which is kind of confusing though, because now you've got to connect the black output into the red. I'll show you what I mean. So we should be in milliamps range for this. We shouldn't need the 10 amp. The 10 amp max. So 200 milliamps. That should be fine. Fingers crossed. So I'm going to disconnect the red output of the supply. And now, so that red output goes into my multimeter's red input. Okay, and then that's going to go through the multimeter and it's going to come out the black end. And now I clip the black end onto the red rail. And then I set it to milliamps mode. And now Actually, that's probably the wrong end to have it on. But we're already here. It's not working. Why isn't it working? Is it too much? What? 0.03 milliamps. Why didn't that work? So I've unplugged it. I've plugged it into the other side, which is theoretically milliamps. But it doesn't work. If I go up to the 10 milliamp, that works. Is the fuse blown on the other side? I don't know that it has, like, actual fuses, does it? I guess it might. Let me try the other one. Oh, the other one's ultra dead. So I should have a battery somewhere. How do I get at it? Do I have to actually take it apart? It has an open arrow, but does that mean the little stand? Or like actually open? Let's see. No, I don't see how that could be it. So yeah, I think I have to take it apart to replace the battery. Okay. Oh, you cannot see this. Okay. So that is 0.3 milliamps. So if we do a little fancy math, do a little fancy math, 0.0 or 300 milliamps. Okay, typical amp hours. a standard 500 to 600 milliamp hours. So if we got 300 milliamps, our battery will last 1 hour. So, tips and quirks. No, let's go here. Optimize. Nope. Optimize power. What has it got to say about that? Low power mode in Wi-Fi scenarios. Looked at this before. But where? How do we configure this? Back. Introduction to low power mode for systemic power management. Very slow powered modes. DFS. Frequency adjustment, don't care. Upon entering sleep, various ways refer to sleep modes. Okay, we'll get there. Max frequency, min frequency. Okay, light sleep in it. Where do we put that? Power management config. Ooh, more code. Power management configuration. Let's do it. We got a lot of prints. No. We do here. We don't need those. Okay. So basically I want this to read 0. But I don't know how accurate it can be. I don't know how accurate it can be when it's set to this 10 amp. When it's using this 10 amp input. So, I guess we'll find out. So, let's see. And yeah, this is completely skipping over the actual regulator thing, which will be present when they have a battery. So, there's that to worry about. Where do we enter this power mode? It says automatically. Enable config PM enable. Component config. Sure. So let's do that. IDF pi. Menu config. Are we in the right directory? Yes. Oh, and this other thing is yelling at us. I think that means it's working. Look at that. So, component config. What did it say? Power management. Power management. It'd be cool if these were better sorted so that there. Support for power management. Yeah. Enable DFS at startup. I want to do that. Enable profiling counters. I don't know if we want that now. What is this? Dynamic frequency scaling, set to default, min set to crystal. I guess it's instructive if we do this ourselves, so we're just gonna do that ourselves then. We'll figure out how to do this, but we do have to do this. Enable debug tracing of PM using GPIOs. If enabled, these functions will keep track of the amount of time each of the power management locks has been held, and ESVPM dumb locks function will print this information. It can be used to analyze which locks are preventing the chip from going into a lower power state and see what time the chip spends in each power saving mode. It does incur some runtime overhead, disabling production. Cool. I'm going to leave that off. Don't care. And then this IRAM thing, put light sleep if enabled. IRAM would sleep longer for... I don't know how much we're using, actually. That's a bit of a failing of mine. I'll have to do some research on that to figure out how much it's actually using in terms of power consumption. I mean, RAM. And ROM. I think it prints out ROM, but I don't know how much... Well, it says it needs 2.1 KB. Let's see. Put idle codes in internal RAM, 180 bytes. There should be enough space in there. Calibrate. Power down CPU and light sleep. Wait, is this? Yeah, it's the right. Oh god. Where'd it go? Oh no. I'm pretty sure this thing is huge. Okay, here we go. PM, cal internal, power down CPU and light sleep. If enabled, the CPU will be powered down in light sleep. ESP chip supports saving and restoring CPU's running context before and after light sleep. Provides applications with simulate CPU, power down light sleep without user awareness. Takes up some internal memory. On C3, 1.6 KB. Reduces sleep current by 100 microamps. Consumes 8.58 KB. And saves us 650 microamps. I mean, why not? I guess it's already enabled by default. So I think these are both this stuff. Well, not this one. What? If enabled, super consumption by about 100 microamps. This has a potential to block the sleep process and cause wake up time to be skipped. Uh-oh. Oh, I forgot I had this. I always forget I have this tea. And I'm self-conscious of making drinking sounds on the mic. But these are pretty good. I think this is the last one, so I gotta go buy more. No, it doesn't really have that kind of mouthfeel or whatever. Okay. So, I think that's good. Let me redirect this lamp. It looks hella artificial, but that's okay. All right. Q. Save. Yes. What have we done? So I got rid of that, and I updated some config for power consumption and buds. dropped the USB cable. Would you look at that? Now that it's plugged into power, it's much less here. But flash, please. Gonna need to remember to amend. Someone drove by outside. Squirrel. It's a pretty nice day. A little brisk. Cloudy. Typical. Typical of Western New York. Now, I don't know if anyone knows this, so let me know. But we got this crabapple tree in our front yard. It doesn't seem like it does apples every year. Like, I'm pretty sure last year there were like maybe 20 to 30 like buds, and about that many like became apples. You know, little crab apples, little green guys. But then like this year it looks like it's gonna go gangbusters. And the year before last, it looked like, I don't remember well, but it seems to like alternate. It goes a year or possibly more without really being productive, and then it becomes productive on a subsequent year. I haven't done any research into whether that's normal. I know like oak trees do that. They do like acorns. They do like a bumper crop so that squirrels forget. They get so many acorns to bury that they forget where some of them are, and the trees have a chance to proliferate more. Yeah. That's cool. It's crazy. I'm wondering if if this apple tree is kind of doing the same thing. Let me know. Let's see. Okay, we flashed it. So I should be able to unplug it. It is not happy about that. Okay, power off. And we'll do power back on. What the heck is this broken off of? I don't know. I just lost it too. Well, I guess it's gone forever. Okay. We're down to 0.2. The shadow makes it hard to see the dot, it looks like. And I can keep an eye on this as well. So 0.2, 0.2. Spikes up to 0.5. Not sure why I did that. There's a little bit of activity. Oh. I'm actually, you can't see it here, but I'm monitoring the web server. So I'm looking at this. 0.2, 0.2, 0.1. Okay, it doesn't look like there's... I mean, I don't know how long it takes to do the print, but it doesn't look like it's that significant of a bump when it does the actual HTTP connect and transmit. So whatever it's doing to keep the connection alive must be taking up the most amount of time. So back to the research on what they recommend for low power oh, and we did say, I keep saying we, but like, well, there's one theoretical viewer, right? At least. Okay. If disabled, which I think we did not enable, DFS will not be active until we configure it using ESP-PM configure function. Let's hit that. S3, please. ESP-PM configure. And here. Okay, so we need ESP-PM. Let's hit that. Why is this open? Go away. ESP-PM. Put that in here. Is in the CMake list file. And here's a trick. You can do... I don't know if we want... or if we want to go that far. Let's do that. Oops. Like that. Here's a trick. In Emacs, if you highlight all these lines, you do LSP or sort lines, and it'll sort them alphabetically, lexicographically. It's a good word. Lexicographical. Kind of a jargon, but whatever. What is it called? ESP-PM. ESP-PM. ESP_PM. Excellent. And then, here's our include. So this is not going to be caught by... this should fail to be included by the LSP. Because we haven't built it yet, so whoops. Build, please. Oh my gosh, what happened? Rev B, yes. Reload the thing. All right, I found it. What else? Blah, blah, blah. So here we are. We want to do ESP-PM configure. Where is it? ESP-PM configure. We'll do PM config is a structure. When DFS is enabled, the APB frequency can be changed multiple times within a single tick. Does not affect the operation of some peripherals, while others may have issues. Peripheral clock sources frequencies will not be influenced by APB frequency, and therefore to ensure the peripheral behaves consistently during DFS, it is recommended to select one of these clocks as the peripheral clock source. For more specific guidelines, please refer to Power Management section of each Peripherals API Preference Peripherals API page. API Reference Peripherals API page. Currently, the following peripheral drivers are aware of DFS and use the APB Freak Max lock for the duration of the transaction. Believe this is the only one we use. Following drivers hold the lock while the driver is enabled between calls to Wi-Fi start and Wi-Fi stop. If modem sleep is enabled, the lock will be released for the period of time. Okay, so then we got to do that as well. So let me make a note of that. So scratch. We're gonna do enable modem sleep or Wi-Fi so that it does not hold onto ESP PM APB Rec Max lock forever. Not using Bluetooth. PCNT. What was that again? What is PCNT? PCNT. Percent? No. Pulse counter. That's right. Okay, we're not using that. Yeah. Nope. Wait. Yeah, here we go. Not using Sigma Delta. Okay. Awesome. So here's the function. What is the structure? Which one of these should we use? So we're on S3. So we should be able to... Well, it seems like we could just use this. But perhaps this comes pre-done? Let's see. ESP PM config. ESP32 S3 underscore T. Okay. Okay, so they're saying just do this. Got it. They should just repeat this for all of them. If they're all deprecated. Okay. So, what are we setting for this? Are there... It looked like there were some of these. Some pound defines. But perhaps not. Well, how do I know how slow? How slow can I get away with? How low power can I go? How low power can you go? How low power can you go? How low can you go? Run it all real slow. How low can you go? Run it all real slow. max frequency. Okay, okay. Go back here. What does it say? Config pointer returns some stuff. Pointer to implementation specific structure. Okay, but then it says it's deprecated, so I don't know. Huh? Okay, let's read this whole thing again. Power management algorithm included. Can adjust the advanced peripheral bus frequency. Put the chip into light sleep mode to run application at smallest possible power consumption given the requirements of the application components. Can express the requirements by creating and acquiring power management locks. Driver or peripheral clock from APB can request be set to 80 MHz. Yeah. RTOS can request the CPU to run at the highest configured frequency while their task ready to run. Yep. A peripheral driver may need interrupts to be enabled, which means it has to request disabling light sleep. Oh, you don't get interrupts in light sleep? Interesting. Yeah. Power management can be enabled at compile time using this guy. Features come at a cost of increased interrupt latency. Extra latency depends on a number of factors, such as CPU frequency, dual core mode, whether or not frequency switch needs to be done. The minimum extra latency is 0.2 microseconds when CPU frequency is 200 MHz to 40 MHz, and frequency scaling is not enabled. Maximum extra latency is 40 microseconds. When you're doing this with the interrupt entry, sure. Dynamic frequency scaling, DFS, and automatic light sleep can be enabled in application by calling function ESPPM configure. Its argument is a structure defining the frequency scaling settings, ESPM config T. 3 fields need to be initialized. This field is usually set to the default CPU frequency, which I think is in... What is the default CPU frequency? I don't know. I have to look this up. Every time. 160? Wait, what is it? What is this? Oh, it tells me exactly what to do. All right. Here we go. Does that actually exist? I have to create it. Oh. Control X52. Create a new frame. Why are they so small? I don't know. And then I have to look at my config thing. Hang on. You can't see this because I don't want you to see my SDK config. It's got my Wi-Fi password in there. I don't want you to see that. You don't need to see that. Crystal frequency. Okay, config ESP default CPU frequency megahertz 160. Yes. Wait. Oh, I see. What a strange thing to do. Okay, I get this. I don't mind showing you this. This is weird. Because it's like the value, the 160 value. Yep, that is yes. And then it says, oh, what's the default value? It's 160. So I'm going to use that. Just yoink this here. Where is this? Dot max frequency megahertz. Yeah. Is that? What else is in here? Min frequency megahertz. 40. Designated initializer. Is there a 40 in the config file? Megahertz. Ooh. Aha! And use the crystal frequency for this. So config extal frequency for that. Light sleep enable is true, please. Light sleep enable true. Hell yes. I guess we'll wrap it in the appropriate error handler type thing. What was it? ESP error check. That guy. Recommended configuration, light sleep enabled false. Why that? DFS. Enabling this option allows the system to automatically enter light sleep during idle periods. Why is it recommending that this not be enabled? Okay, recommended configuration and configuration steps for okay. Minimum idle tick count before entering sleep. Sure. But light sleep related codes in IRAM, RTOS. Wait. Well, so over here it says disable it. I assume. Unless it's like weirdly active low, which would be very strange. Yeah. Oh. Why this? This is strange format. Other configurations except wake up source related configurations. Okay. Enter deep sleep. How do we know when to wake up from deep sleep though? Wake up sources. Wake up. Wake up. Wake up. Wake up. It's some real rage against the machine. Coprocessor wake up, sure. UART wake up, light sleep only. Yeah. Power down, no. Power down to flat, no. Configuring IOs for deep sleep. Who can wake up? Wi-Fi motor suit. Wi-Fi power save example. Hello. That's what we want to do. Oh look. Typical graph. This is exactly what I was trying to draw a few streams ago. We're like, hey, look, it spikes and like stays awake. With management disabled. Wait, what's the difference? So it peaks at max current 342, max current 338, average current. Oh. See? Very close to zero, more of the time. Right, so, I mean, it's going to spike up to exactly the same sort of spikes for the most part. I guess this one's a little higher. Max current at 338 versus 342. But, yeah, but generally it's lower. The bottom is lower. See? Closer to. So here's 50. Here's 0. Here's 50. Here's 0. Here's the line. Much lower. Much lower on this example. So let's follow its lead. PowerSave.c. Event handler. Okay. Init, config, default. This all looks familiar. Listen interval. I don't remember that. Let's see. Get rid of this other window. Listen interval in the Wi-Fi service. Listen interval. Default listen interval? What was it called? Default listen interval. Where do you come from? Oh gosh. Okay. This is defined somewhere up here, so we'll just pop that in there. Config ESP30. No. What are we calling? I called it something. Compost probe config. Compost probe config. Yeah, I guess I can just do config compost probe. I don't know. Config ESP Wi-Fi listen interval. Screw it. And then there was another one. Default beacon timeout. That's a new one. Default beacon timeout. Config Wi-Fi beacon timeout. Okay. What else? Okay. So station. Wait. Okay. Here we go. Let's do this. Other way. Get rid of this stupid thing. I wish I could scale just the font of the body. But no, that would be too convenient. Get rid of the strap. netif init. I think we do that in main actually. Netif? No. Oh, it's right here. Doi. Netif init. Loop create default. And then create default Wi-Fi station. Oh, I see. Okay. And then it's this is just creating a check for this. Does it actually use netif later? It's just checking for nullness. Netif it. No. Netif t. Oh. Clean that up. Meta z. There. Okay. And actually, just do this here. Okay. Assert sta netif not equal null pointer. Did you mean assert fail? No, I meant assert, but I might have to include it. Pound include C assert. Okay. Then config init, handler, Wi-Fi config. The only thing it sets is this default listen interval, which is expanding to nothing because we're not configuring that yet. Oh, but then it does do get AP SSID. Whence it's getting that? Where's it getting that from? Get AP info? Ah, these are just helpers, maybe? Are they fancy? They storing stuff in like Flash? Get AP from standard in. No. No standard in. Back to power save. Okay. Listen interval, SSIDs, password, sure. Connecting, spoiling the contents of the password. Wi-Fi set mode. Mode station. Wi-Fi IF station. We set config, and then we do. We expect the client to do this. Call start, which will call Wi-Fi start. SoC wipe support 5G. I'm not sure if we do that. Aha, but then we set this. This is the key thing. Reduce power consumption by making the Wi-Fi chill in an inactive state for most of the time. ESP error check. ESP Wi-Fi set inactive time to Wi-Fi station default beacon timeout. Okay. And then what is PS? PS. ESP Wi-Fi set PS. Default PS mode. I don't know what that is. You exist in here? Default PS mode. Power save. Okay. Roll this in here. Okay. If config ESP config example. Why is it saying config example? That's so weird. Oh, so config Compost mon. Config Compost mon power save min modem pound define default PS mode to Wi-Fi PS min modem. Okay. So there's a few of these that I'm just going to copy and replace string config example underscore with config compost mon underscore config power save mode. Config power save modem. That is not what this is called. Config Compost Mon power save modem is what it actually is. And then we've got a few things to set in the menu config thing. Kconfig project build. So, kconfig mode, please. So we got compost something something. That's not actually my password, in case anyone's freaking out. My one theoretical viewer is freaking out. Welcome, by the way. Thanks for chilling. Let me change this. Config ESP Wi-Fi. No. Config Compost Mon. Config Compost Mon. Okay, so Compost Mon. So I believe this will create something called config_Compost Mon. Right? Because that's how it works with the Compost robe config. We got config ESP Wi-Fi SSID, config ESP Wi-Fi SSID. So we do the same thing here. Compost Mon. Oh, bloody hell, where'd it go? Okay, here it is. Compost Mon Wi-Fi listen interval. String. To describe what it is. I guess Wi-Fi listen interval. Well, let me take a look at it. It's in here, so it must be in here somewhere. Main project build. Okay. Example get API from it. Wi-Fi SSID. Wi-Fi listen interval. It's an int. Untabify? No, tabify. Well, I don't like it. That should be tabified. What is tabify? Control I. Alt I? Okay, there we go. I'm stumped. Okay. But then it's got a default. Okay, show me. Give me just one. And then, Okay, default of 3? 3 what? 3 seconds? Help. Interval for station to listen to beacon from beacon from AB. The unit of listen interval is cool and whatnot is, that's an O, is 1 beacon interval. For example, if beacon interval is 100 milliseconds and listen interval is 3, the interval for station to listen to beacon is 300 milliseconds. I think I understand what it's saying. Wrap? No. Indent. According to mode? I'll just leave it be one long thing. I'm okay with that. Yeah, I'm okay with that. Okay, what else does it have? It has one other thing. The config of Compost Mon Wi-Fi Wi-Fi beacon timeout. Hit it with the Alt-I int. Wi-Fi beacon timeout. Default 6. Sure. Well, I'm not sure what that means, and I'm not spelling default correctly. Range 6 to 30. And for station, if the station does not receive a beacon from the connected soft AP. All right, just copy this. I'll read it, but come on. Come on, be good. There. Oh, does it not like lowercase if, maybe? But it's in a block of sorts, so should be fine. For station, if the station does not receive a beacon frame from the connected soft AP during the inactive time, disconnect from soft AP. Default is 6 seconds. Okay. Wi-Fi band mode, don't care. Example, power save mode. That's one of the ones we want. Okay, that's the other one we want. Config. No, choice. Yes, choice. Example, power save mode. But what did we end up calling it, actually? Power save config compost mon. Compost mon. Power save mode. Power save mode. We can shift over a little bit. There we go. Power save mode. Prompt. Prompt. Power save mode. Sure, sure. Easy prompt. Exactly what it's called. Default is... Ah, shoot. What do we call it? Power save... Wait. Yeah. Power save min modem. So kind of what it says. We just replaced example with not example. So default is compost mon power save min mode m. Help power save mode for the ESP32 to use. Modem sleep mode includes minimum and maximum power save modes. I'll read this from my editor. That's not how you copy. Bloop, 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 bloop. Paste. Get rid of that. Properly indent this. Like that. Tab for indent region. There we go. It's not pretty, but it's fine. Okay, and then the options are no. There it is. Config example. No, not example. Compost mon. Power save none. Config compost mon. Power save min modem. Config compost mon. Power save max modem. And then we go cool. No, not like that. Come on. Come on, indent properly. Cool, none. New line. Alt-I. Cool. Minimum modem. Cool. Maximum modem. Max power. And choice. Bada bing. I don't know if I want to do this thing. I think I've already set some values somewhere. I don't care. I don't care super much. We got a max and a min. I don't need it to be configurable for myself. Pull requests accepted though. Okay. Well, I don't know. Allowed. I'll say pull requests are allowed. Can't guarantee I'll accept your pull request. Okay. Is that going to build? No! Why? Did I spell beacon wrong somewhere? Compostmon Wi-Fi. Compostmon Wi-Fi. Beacon. Timeout. Also, listen interval. Config compostmon listen interval is not. Did I not include the right file? Compost probe config is in there. So compost probe config. That pulls in SDK config. So I shouldn't need to now re-include that myself. What is it saying is missing? Default listen interval. What the hell did I just do? Okay, there we go. Default listen interval. Config compostmon Wi-Fi listen interval. Compostmon Wi-Fi listen interval. Doesn't it prefix everything with Doesn't it prefix everything with config? Because that's how these work, right? Unless I'm totally looking over it. Config. Oh wait. Where does server host go? Whoops. In main? Yeah, main. Server host. Config underscore. Yeah. There's a config underscore. That's just thrown on to the beginning. So I should be able to take this. Paste it in here. Do a compare. Is one of these things not like the other? Interval. They look the same to me. Do I need to run a config? Is it not smart enough to pick up the... Maybe it's too dumb. So, menu config. Compostmon configuration. Oh no, it's too late. You've seen my password. Yeah. I won't belabor it. There they are. So I'm gonna hit Q. No changes to save. SDK config. Well, it's in here, so whatever. Compostmon. Config compostmon Wi-Fi listen interval is there. It is there. I see it with my eyes. So build. Okay, it just needed to be touched, I guess. Okay. Let's turn this off. Plug it in while we wait for the build. We're chilling. Very chill. Like 60 BPM or so. It's down there. It's definitely down there. Down tempo. Wait. Hit me with the flash. So those are going. Okay. I think that's it running. So this is off. I've unplugged it. Now we're going to turn it on. So you can kind of see. Not looking like it made a big impact. Okay, based on free art, if automatic light sleep voice is not enabled. Wait. Oh, I just jumped from somewhere. Where'd it go? Free Artos. Here we go. Automatic light sleep is based on free Artos tickless idle functionality. If automatic light sleep is requested while the option config free Artos use sleep tickless auto idle is not enabled in menu config, ESPM will return ESP error not supported. I don't believe it's doing that. Let's see. I guess we need to plug in to see. I'll plug in. And monitor. Monitor. Aha. Okay. So we gotta hit it with. Oh. We gotta hit it with the menu config. And then here. Free Artos, maybe? Free Artos, yep. Kernel port. Where's the tickless thing? kernel. Tick rate. Check for stack overflow, canaries, minimal stack size, sure. Idle hook. Max task name length. Use timers, core affinity, task priority, blah 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 blah. Tick the idle. Oh, what? Config. Expected idle time before sleep. 3 cycles? That's fine. We'll save that. I'll save that. Flash. Monitor. Tired already. I want this to be done. I want it to work. I want it to not take so long to compile everything. Ugh. Generating blah blah. 7 equal blah blahs. This is boring. Thank you to my theoretical viewer for watching. At least the music's chill, you know, it's a vibe. There's a vibe to it. Could be more exciting. I know streamers like I think Primogen uses EDM on his streams. Okay, that looks like it's working. So I'm going to stop monitor. I'm also going to turn off that supply, and then I'm going to unplug it. Let it die. And power on. Oh. All right, we're at 0 because I don't think we can measure any lower than that. Unfortunately, we have no way to switch back to the milliamp rate. I think this... I guess I don't know what happens to the accuracy. Oh. It's alive! Okay. Cool. So now I just need to know. Now I need to know what actually is it doing every 30 seconds. And I should redo the voltage divider for the moisture sensor. So let's do that first before we start measuring more stuff. Hello. Welcome to the other screen. All right, if I get really loud, I think you can still hear me while I finagle this stuff. So first, I'm going to move the ammeter to the other side of the regulator. little bit of organization, a little bit of cleanup. I think that's good. And then, yeah, ammeter on the other side. And I'm just kind of sticking that in so it's just not just loose up off the board there. So I know this looks weird, but we're going out through red. This is just connected to itself, so it'll come back out. And then through this guy. You can't see the posts. There we go. You can kind of see the posts. There we actually go. How's that? I'm dumb. There. So out the red into ammeter, black out, back into the positive side of this guy. This regulator, drop it down to 3.3 volts. That'll go into our system on chip. Power everything up. Okay, and now I can do the recreate the voltage divider. I don't remember the values of these resistors that we used, but I know that I don't actually remember what pin are we using as ADC input. That's important to know. Let's see. ADC one shots. Channel 0. Oh, but ESP hardware reference. Dev boards. There we go. Oi. No, that's not what I want. I mean, that's kind of what I want, but not the... There was like a dev kit. Here we go. Dev kit C? That's the one. Yep. Hardware reference. ADC channel 0. ADC1 underscore channel 0. That is pin number 1. Number 1. We've got a resistor to ground. then from there up to the actual capacitor soil moisture sensor. And then so actual pro thingy. Yep, so now we got that and power. Alright, can you see that? Not very clearly. So voltage comes in from the capacitive sensor on this orange wire. You can kind of see the resistor going over to the same node as this yellow jumper, and also this resistor which goes to ground. Yeah? So I've shown this before. Let me bring up the voltage divider diagram. Aha! So, in this example, Vin is the output of the capacitive sensor, the orangish color. I don't know why I'm pointing at it. It's way too small. But yes, orange out of sensor is Vin. Goes through this resistor, which means that there's going to be voltage drop into a range that we can actually read with our ADC. So that's where V out is connected. And then we got a resistor back to ground. There. Which just makes it so that the voltage here is what we want it to be. I don't know if that makes sense. Hopefully that makes sense. I can explain it again better. If that helps. But jump back. Boom. Now we can start measuring the actual voltage. The actual current when we're really using this thing. Set it to ammeter mode. Actually, let me try it at a lower range. Yeah. Let's give it a shot. Okay, power's on. It looks like. So it's still at like 0, which is good. Now the question is, I'm looking at it over here. Are we going to get readings on the server? So it should be every 30 seconds, I think. Nearly there. There it is. So it's alive. It's alive and running. I don't think I saw it even spike on the ammeter. I mean, these aren't very good. They're not that good. They're not going to catch it in real time, but we got it. We got our measurement. We can check here for data from today. And you can see all the readings. The latest reading was at 11:10. 11:10 p.m. That's not right. It should be 9? Is it currently 9 UTC? Current time UTC. Come on, don't do that to me. 21, not 23. Wait. Today's not the 1st of May. Today's the 8th of May. Aha. There we go. Look at that. It's been warming up in here too. Interesting. So these are real readings from this probe. Oh, it's because it's right next to the... I think it's because it was right next to the supply. Cool. So we got some trends. Humidity. How's that going? I think as temperature goes up, generally humidity feels lower. So I'm okay with that. Okay. And I wish the resolution on this seems to be... It seems to be, regardless of the measurement frequency, it's putting in... No, I think it's right then. Okay. Yeah. Very cool. All right, now that we have that, I don't know that I want to do anything else today. Actually, I kind of do want to look at... Let me look at the database. Or no, I can just look here. I can just look at these readings. So it should be giving us a moisture reading of something. 15, whatever. Okay, so this was it disconnected. This is just noise. Completely random. Randomish. Not completely, but kind of close. So this is closer to the air temperature. This is closer to it's wet. So like a percent, inverse percent, I don't know what the word is. It's inversely proportional to wetness. So the higher the value, the less wet. That's cool. That's fine. Should we try it with the battery? We could try it with the battery. Thought I had more of these clippy things for 9-volt batteries. If I do, they're in my storage over there. Okay, the other thing I gotta figure out, these leads are tiny on this thing, and they're not really meant to be put into a breadboard. I could try using the clips. Strip these a little more and use the clips. Let's do that. have the battery clips with the leads that are way too short. I've got these like manual, mostly manual. They can be adjusted. They have this like screw where you can slide it so that it adjusts the depth, but it's easier to just kind of go by hand and feel without this thing. So I'm just gonna do that, but then I'm also I want these. Do I want to probe? So I got the 2Bs, the little the 2 furs. But then there's also these 3 furs that I'm wondering if I'll want to like stick a probe into. Maybe. Let's do the 3Bs and future-proof it for that. We'll at least get the voltage from it if we do it that way. We can read the voltage. These should all be connected. Yeah, they're all connected to each other, so we'll do that. I just need 2 of these. Gonna strip this. I don't know. That's hard to do. Because I think these are stranded. So it's hard to do. If you're not super careful, or like there's something on the end, like leftover solder, you might pull out strands, break them. These got a good length. We'll clip into one of these. Red. Ouchies. And then one of these jumpers. Jump in there. Flip. Red. Black one. Aha. Can kill that. And also now, all right, so theoretically, let me grab a 9 volt. I will be term down. Just give me 1 minute. BRB. It didn't actually switch to BRB mode. I spent all that effort. Anyway, I'm back. I got a battery. This might be kind of old though. It says used before March 2021. So might not be good. I do have this multimeter that can measure the voltage on this battery and see how it's doing. The plus end is the small round. .95. Thought there was a battery mode as well. So let's see. Let's poke it. So there. Nope. Oh. 8.9697. That's fine. That should be okay. It is a little old, but still working. Okay, back to ammeter mode. Can we keep it at the microamps? I don't think it can show us that. We'll see. I mean, I'm not even sure that's working, to be honest. But yeah, workbench. Okay. Battery is connected. That should be going. I think it is. That's a little clearer. You could kind of even see the dot. So that's 0.00. And where's it at? I'm trying to keep an eye on my periph to see when the network activity goes, do I see a spike? Yep. Yes, indeed. 0.01 is the detected spike. But yeah, like I said a little bit earlier, these things aren't very like high time resolution. So it could be spiking way higher, but for a lot less time than it can measure. Yeah, so that is on and running off of a battery. How freaking cool is that? I think that's awesome. I think that's dope. This is pretty, I'm pretty psyched. The next thing to do, I wonder what else we should do with it. I don't know. Let me know what you think. I'm curious. What would people like to see? I am still planning on turning this into videos. Now, I think now is the time to really start working on the video aspect of it. So next week, I'll probably on Tuesday and Thursday, I'll probably be, maybe I'll just take the time and do the scripts on stream, and hopefully get some input from y'all nerds. Yeah, it would be cool. It would be cool to get a little bit more active chat going. But, you know. So, yeah. Back to... Let's go back to this. So here's the data collected today. Our little board. I guess I should measure... I guess I should measure the current with an oscilloscope rather than just using the multimeter, because the multimeter is not accurate at the level we want it to be. And often the problem with some of these things too is that even if the multimeter were able to go down to the microamp stuff, like you'll blow past that when it like boots up or turns on a radio and stuff like that. Those things tend to draw quite a bit of power. So, you know, while you're in super low res or super high res, you're going to be blown out by the spikes in the current, and then when you're at super low res, you're not going to see anything. So yeah, might be worth it to get a... There are like... what are they called? It's like a brand name. These like... Power Sharks or something like that? What are they called? Power consumption meter. Energy monitor? No, I don't think that's it. These are just clips. Well, they go in your, yeah. They go in your whole house. Frequently returned. Interesting. Let's see why it sucks. Excellent product. Don't buy, mine was used. Less useful and reliable. Both UI and smart device detection have deteriorated to the point where it is a waste of time even trying to make sense of work. Low detection is useless. Stop sensing all my connected KP115 TP-Link thingies. Sure. Yeah, I don't know. No, I was thinking of plug-in power meters. What? These are what I was looking at. But that's not exactly... No, go back. What the hell was that? Smart home review. Is there a blacklist for it? I thought these had like a clever product name. I don't know what happened. Where? Usage monitor. Like a milliwatt killer or something, like something like that. I don't remember what it was called. I remember getting one for my dad. Yeah, plug in watt meter. Plug in watt meter. Okay. Is there recommendations? No? From the Homes Depot. Yeah, I don't know. This looks good. Still want to... I guess I'll make a note of the time when this thing started, which was at 5:15? What about that sticky note? Oh, it's underneath. Okay. Battery. Start. At, 5... What time was it? Can I look at the VOD? Is it too early to look at the VOD? Let me see. How far back in time do I need to go to see? Where's my... Can I view my channel? No. If I go to my page, here we go. The current broadcast at how far back? Okay, no battery there. No battery there. No battery. Oh, yep, we're getting there. Okay, at 3 hours and 8 minutes in. 3 hours and 8 minutes in, so 10 minutes ago, so at 5:17. So the battery started running at 5:17. And I'll just, I have a whole box of these. These are old, so if I don't use them, they're gonna get thrown out anyway. So I might as well do that. And I'll keep an eye on when it dies. And I could see that in the data from the application here. I will see a last measure. I'll get a 30-second resolution on when it dies. That's pretty good. And I don't even need that much. I don't even need that much resolution from these measurements. I set it to 30 seconds, I think, so we didn't have to wait so long to verify that it was working. And then this should be doing almost... Well, where is it? Here. 5 seconds of liveness. Should be doing almost nothing. Yeah, maybe I should... Maybe I ought to disable the ammeter, because that's not useful. So let me do that. So I don't have to replace the battery on that thing. still works. That's cool. I was expecting it to die. All right. It's 5:30. That's a pretty short stream. I think it's only I can see the number. It's only been 3 hours and 20 minutes. Started a little late, ending a little early. I think. Yeah, I'm in a good spot. This is cool. I'll start working on scripts for a series of YouTube videos. I already did kind of start working on them. I haven't hunkered down and done it seriously. So I think that starts pretty much today and in through probably spend time doing that on stream Tuesday. And like I said, I got some vacation coming up that I'm going to take with my fam and some friends. So I'll be out for... I'll have next week. Next week I'll be on, and then Tuesday, but then I'm out until... So 3 more streams after this, and then I'm out until June. Yeah, let me know. Thanks. Well, let me switch views. Let me know. What was that? Did I lean on something? Let me know if there's anything you'd like to learn. You can check out my, social media links. Follow me on there. Check out my personal website. I've got a few blog posts on there with some cool stuff that I've done that you might be interested in. Ask me questions, whatever. Ping me on Blue Sky, Twitter, LinkedIn. Oh, LinkedIn. The kinds of posts on LinkedIn that I see from it's never people I know, which is cool. It's never people I know posting like the super cringe stuff. But yeah. So that was an experiment. That I posted on LinkedIn today. Very strange. I don't know. I don't know that. I don't. Yeah. It doesn't feel quite right to be posting on LinkedIn. Something about it's like. I think the problem is that it's not really live. Nobody has LinkedIn turned on just to browse. They're always just like the emails that you get when you open it up, and it's like, hey, someone made a post and you haven't seen a post by them in a long time, so here it is via email. And then they'll open it up and then they'll interact with it and you'll get some traction on a post that way. But it's just not, I don't know, it doesn't look, it's not a really live social network. Everything on there is like kind of shit posting for the most part. It looks like AI posting and like inspirational stuff. Yeah, I don't like LinkedIn. But yeah, what was I saying before I got off on the tangent was basically, let me know if you're interested in anything in particular. If you've got any questions, I'm open to answering questions, especially on stream, like live questions. I'll stop what I'm doing and do that. If there's anything you want me to cover, if you want to see like SPI, or I've never done like CAN bus, so I'd be happy to like explore that. If someone comes in and says it'd be cool to see how that works, I could try to find some devices and show them off. As far as I know, I'm the only person streaming embedded systems, so that's cool. I found a niche, maybe. But let me know what you'd like to see. The live development of a system is cool and all, but I think it's pretty limited. Because once you run out of system to develop, you're kind of done. The project's over what do you stream after that? So I'll have to figure that out. Maybe it's just find a new project, integrate that, and see how it goes. I'm also pretty good at C++. Let me know about if you're interested in that. Yeah, any questions you got, I'm happy to answer. So with that, thank you for watching. Thanks for watching the VOD. If you're watching the VOD, I believe it's youtube.com/@josecodes. I'm going to start putting this stuff up. Some overlays for this. Yeah. youtube.com/@josecodes. That's where all my VODs are. I don't have a quote-unquote main or alternate channel. I might need to do something like that. Maybe rename the current channel to Jose Codes Live to separate it from Jose Codes, which should be like real videos. I think people do that on YouTube. I don't know. I don't know how all this algorithm stuff works, this content creator business. I don't know. I'm doing this for fun. I'm doing this because portfolio work, I guess. It looks like people can see how you do what you do. And I'd be really excited to teach folks if only there was someone asking me to teach them. With that, again, thanks for watching. I'll catch you later. Peace out.